Hey everyone, this is Adam from the Fedora Modularity team, and in this video, together with Tomasz, we'll show you how to build a modular container and how to deploy it on the host in the standalone scenario. And I also created this picture that describes all the steps we need to do to make this happen. So let's have a look. The first step is building the module itself, and it's done by the module build service, MBS. So we need to write a modularity file that describes which packages are present in the module. For this example, we used Nginx web server, and we built it in the production Fedora infrastructure using the same command as Ralph shown us in the previous demo. When we have the module ready, we can build a container out of it. And for this, we won't be using OSBS because we are still not ready to use it, but we are using images in Docker Hub. And to build the container, we use this 3-layer module container architecture, which is layer 1 base runtime, created by the base runtime team, layer 2 packages, which will be created automatically by the infrastructure in the future, but we still needed to do manually right now, and layer 3 is all the configuration and the real container stuff. So let's have a look at the layer 2 example, which is using base runtime, adding the modular repo from Koji and installing the module itself. And the final layer adds all the configuration we need to run the container. One interesting thing here is that I mark basically some configuration files to be mounted on the host to run it in the standalone scenario. And when the container is ready, the step 3 will be to run it. And as I said, Tomasz will be deploying it in the standalone scenario, which means that the image and all the configuration files will be tracked by RPM on the host, and you will be able to start the service using system control. So the user experience will be the same as using RPM packages. So Tomasz will show us how to deploy it.
Hi, I'm Tomasz, and let's run the container Adam just described. We will run it as a standalone container. So what that is? These are managed by systemd unit files. They have data stored persistently on a host system and then mounted inside the container. Also, on the host system, the files and directories are tracked by RPM database. You can only have a single instance of a standalone container, and standalone containers run in network namespace of a host. In the end, we would like them to be installed via DNF, but this is in works. So what we did, we created a real example of standalone container, which is Nginx image. It's in here, and as you can see that it's a Docker image. So what we'll do right now, we will install it on my laptop. By installing, I mean that the script I wrote for this demo, it will take specific files from the container image, create an RPM from them, and install it on my laptop. So this might be familiar to you from atomic command, and in reality it's very, very similar. So the reason I didn't use atomic command for that atomic command uses run C to run the containers, but our team is targeting Docker containers because it's infeasible for us to write run C manifest files for Fedora 26 for all our images we are planning to deliver. Since the script uses the same internal API as Atomic's using, I think it will be pretty simple to merge it back to Atomic command. And that's what we'll be doing probably next sprint. So let's install it. So the first thing you will see is that the files will be copied from the container image, then we will create the RPM from it, and finally we will install it. So right now it's installed. So let's see, it's in here. So we can see all the files which are on the host. Let's check the service via systemd. So we can do status. This is from my previous runs. So let's start it. Right now it's running. We can open it in browser. It works. So let's change something since all the files are on my host. Now we need to restart it. And now when I refresh my browser, you can see the updated header. And we can also check whether some files changed. And you can see that file has changed. So you just saw a pretty seamless experience when the service is running in a container and it's tightly integrated into the host. So all of our muscle memory pretty much works. So that will be all from me, and thank you for listening.